Colby, 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 math.com.
Here are the answers for Learning Opportunity 7.13, 7.13. Send me the grade for this by the end of the day. The minus number, please. Number 1 is 540 centimeters cubed. 2 is 180 centimeters cubed. 3 is 628 inches cubed. 4 is 209 3/10 inches cubed. 5 is 2,700 meters cubed. 6 is 35 1/10 feet cubed. 7 is 706 5/10 centimeters cubed. 8 is 7 2/10 meters cubed. 9 is 166 7/10 milliliters. 10 is 408 9/10 grams. 11 is 144 inches cubed. And 12 is $1. When you do this, when you shaded in all the correct answers, you get the answer to the riddle. What do you call a monster with a car in his head? Jack. And so here's a car jack, incredibly strong machine holding up a car, and it might even be a better riddle if we said, what do you call a superhero with a car on his head? Or you see the Hulk lifting up a truck above his head right here. Now, if you missed one or more of those problems, I hope you'll fast forward to the problem you need, because I'm going to do every single one of these 12 problems on the video, but you shouldn't watch the whole video. You should just go to the problems that you need help with. All right. Number 1 is at first glance I thought it was a cube, but I see it's a prism, a rectangular prism. The volume of any prism is area of the base multiplied by the height. And the formula for area of the base of a rectangular prism, since the base is a rectangle, is base times height. So in this case, 10 multiplied by 6. The area of that base that I shaded blue is 60. And the volume is 60, that's the area of the base, multiplied by the height of the prism. Now has nothing to do with that base rectangle. It's how far apart are these bases. What's the perpendicular distance between those rectangular bases? And it's 9. And this is why the answer to number 1 was 540 centimeters cubed. And I'm going to just double check myself as I go here. Yeah, I see it right there. Okay. Number 2 is a pyramid. It's got a rectangular base, but it only has one base, so it's a pyramid. So we have to start by writing the volume formula for a pyramid: 1/3 multiplied by area of the base multiplied by the height. And then we find area of the base. The base is a rectangle, so base times height. This rectangle has a base of 10 and a height of 6, so the area of that rectangular base is 60. And when I substitute that into the volume formula, 1/3 multiplied by 60 multiplied by the height is the perpendicular distance from this vertex called the apex to the base shape. You see they're indicating it's perpendicular, and there's a distance of 9. That's the height of the pyramid. 1/3 of 60 is 20, and 20 times 9 is 180. Units will be centimeters cubed. Looking for it here. There it is. This is a cylinder, so we're using volume equals area of the base multiplied by the height. The base is a circle, so the area of the base is pi r squared. Cylinder is just like a prism, just with a circular base. We're going to approximate using 3.14 for pi. And the radius is given directly. It's given as 5 inches from the center to the edge. They haven't given us a diameter. They've given us a radius of 5. So 3.14 times 25 is, I should really have that memorized. That comes up all the time. 78.5. So the volume is approximately, I'm saying approximately now because I approximated the area of the base by using 3.14, so now my volume becomes an approximation. 78.5 multiplied by the height, which is 8, the perpendicular distance between the circular bases. And if I multiply 78.5 times 8, I get 628 exactly. course, this is not the exact volume because we use 3.4, but the units would be inches cubed. Make sure I find it down here. There it is. Number 4. This is a cone. It's like a pyramid but with a circular base. So volume equals 1/3 multiplied by big B, area of the base, multiplied by the height of the cone. Big B, the area of the base, since it's a circular base, is pi r squared. So the area of the circular base is approximately 3.14 multiplied by 5 squared. We just did 3.14 multiplied by 5 squared. That was the circular base of the last problem, so that's 78.5. So the volume is 1/3 of 78.5 multiplied by the height of the cone is 8. 78.5 is not easily divisible by 3, and neither is 8. So I'm going to do, on my calculator, I do 78.5 times 8. And then I just divide by 3, because multiplying by 1/3 is the same as dividing by 3. Dividing is the same as multiplying by the reciprocal. So that divided by 3 is 209. 209 and 3. The 3 repeats. The 3 goes on forever. I should have put this as an approximation also. It's 209.3333. It goes on forever. And so that's why you can see that they rounded it here, if I'm remembering correctly. Right there. 209.3. They just rounded to the nearest tenth. Now, interestingly, this will be helpful in some later problems, because we notice that this cone has the same circular base and the same height as the cylinder. It's 1/3 of the volume of the cylinder. That's where that 1/3 comes in. This is clearly taking up much less three-dimensional space than this cylinder. It takes up exactly 1/3 of the three-dimensional space. Number 5 is a little tricky in the dimensions, and also in calculating the base shape. But the key to understanding number 5 is seeing that this 27 meters is the perpendicular distance from this vertex to this face. And the only reason they would be showing us a distance from this vertex to this face is if this face was the base of the polyhedron. And if it has one base and it goes up to this vertex or apex, then it must be a pyramid. It's a pyramid with a triangular base, so it's a triangular pyramid. So we start with the volume formula for any pyramid, 1/3 multiplied by big B, the area of the base, multiplied by the height. And then we find big B. We find the area of the triangular base. The area of a triangle is 1/2 base times height, which is why they're showing you that this 20 and this 30 on this triangle are perpendicular. It's a right triangle. And so you could make the base 20 and the height 30, or the other way around. It wouldn't really matter, but I'm just going to say my base is 20 and my height is 30 for that right triangle. 20 times 30 is 600, and half of 600 is 300. I guess it would have been easier to take half of 20 as 10, and 10 times 30 is 300. But in any case, the area of that triangular base shape is 300. That's going to be convenient because 1/3 of 300 is 100, and we're going to multiply that by the height, which is 27. So 100 times 27 is 2,700. The dimensions were given in meters, so the volume is meters cubed. And I just want to always make sure that it's on the puzzle here. There it is. Shade that in. Number 6 is a pyramid also, but it has a square base. You can tell by these marks of congruence here. But I start with formula for any pyramid, 1/3 multiplied by area of the base multiplied by the height. The area of the base, since it's a type of a parallelogram, it's base times height. I could have written side times side for a square, but it's 4.5 times 4.5, which is 20.25. So the volume is 1/3 multiplied by 20 0.25, parentheses might be better notation here, multiplied by the height, which is 5.2. Now 20.25, if I add up those digits, I get 9, so I know that's exactly divisible by 3. So I kind of want to do this mental math. 6.75, I believe, times 5.2. I'll do that last part on a calculator and see if I got the first part right. 6.75, to help if I put in the right number. 35.1. 35 1/10 feet cubed. We'll be right if we find it down here. There it is. Alright, so that looks good. 7 is a cone. It's just, it's upside down. Or right side up, I guess, was an ice cream cone. You'd want to hold it that way so your ice cream doesn't fall on the ground. Volume is 1/3 times area of the base times the height for any cone. The area of the base of a cone is a circle. And so pi r squared. But be real careful on this one. I saw it when I was shading it. They haven't given us the radius. They've given us the diameter. So I'm going to substitute 3.14 as my approximation for pi, but for radius I'm going to put 7.5, half of 15. 7.5 squared is 56.25 times 3.14. 176.625. So the volume of the cone is approximately 1/3 multiplied by 176.625 multiplied by 12. And here's an opportunity to associate to our advantage. I don't want to multiply 1/3 times 176.625. I want to take 1/3 of 12. And because it's a series of multiplication, I can do that. 1/3 of 12 is 4. So my calculator, I'm just going to do 4 times 176.625, which I almost want to do in my head. 680, 704, 706.5. Let's do it this way just to be safe. 706.5. Centimeters, so centimeters cubed. 706 there it is. Numero ocho. Another weird pyramid though, pyramid certainly. The key here is seeing that this 4 is at a right angle to this edge, which means it's a right angle to this base shape. And so it's a triangular pyramid. And so volume equals 1/3 multiplied by area of the base multiplied by the height. And the base is 1/2 base times height, because the base is this triangle that I've shaded blue. So the base equals half of 3 times 3.6. Half of 3.6 is 1.8, so I'm just going to do 3 times 1.8. 5.4. I don't know why I needed a calculator for that. That was pretty easy. So the volume equals 1/3 multiplied by area of the base, which we've just determined is 5.4. I'm going to use parentheses. Multiplied by the height of the pyramid is 4. The perpendicular distance from this apex to the base shape is 4. 5 and 4. 5 plus 4 is 9, so I know this is divisible by 3, so I get 1.8 multiplied by 4, which is 7.2. Volume is 7.2 meters cubed, which is right there. Number 9, an ice cream cone. Oh, we're making a joke about a cone. An ice cream cone. Okay, there's my ice cream cone. Here's proof that you don't have to draw it well, you just have to draw it. It's a diameter of 7. Diameter of 7. 7 equals diameter. So radius equals 3.5. I'm going to do that right away. And a height of 13. That means from this apex to the base shape, the perpendicular distance is 13. How many millimeters of melted ice cream can it hold? I like how they said melted ice cream here because it can hold more than its volume of solid ice cream because you know how it heaps over the top. So it's pretty clever of them to change it to melted ice cream because once it's melted it will be level with that base shape. That's pretty smart wording, and I don't think I've ever noticed that until now. And then they say 1 cubic centimeter is 1 milliliter. That's true. So if we find the cubic centimeters, we found the milliliters. There's a 1-to-1 conversion, so that's going to be easy. Volume for a cone is 1/3 multiplied by area of the base multiplied by the height, and the area of any circle is pi r squared. So approximately 3.14 multiplied by our radius, because we noticed they gave us a diameter. Our radius is 3.5, which when you square it is 12.25. So I'm going to do 3.14 times 12.25. 38.465. The approximate area of that circular base, and so the volume will be approximately 1/3 of that multiplied by 13. No friendly numbers that are jumping out at me, so I'm just going to find this product first. I get 500.045. I'm dividing that by 3 because multiplying by 1/3 is the same as dividing by 3. And I get 166.6816 repeating. I'm just going to round it to the nearest tenth. 166.7 centimeters cubed, but they told us every cubic centimeter is 1 milliliter. So that's also 166.7 milliliters, which is right there. So we did it right. Number 10, the steel machine part at the right has a base area. Oh, they gave us big B. See, big B is 22 5/10 centimeters squared. They're giving us this pentagonal area and a height of 5.8. They haven't shown the height. None of these edges are the height. I'm gonna grab a red color here to make this clear. The height is the perpendicular distance from this apex to this base pentagon that I've shaded blue. And so the height equals 5.8. Well, the steel weighs 9.4 grams per cubic centimeter. How much does the part weigh? Well, first we'll need to know how many cubic centimeters we have, so we're doing the volume calculation first. It's a pyramid. It has one pentagonal base. It's a pyramid. So 1/3 multiplied by area of the base multiplied by the height. But in this problem, I don't need to go calculate area of the base. They gave me area of the base. So the volume is 1/3 of 22.5 multiplied by the height of 5.8. I'm going to do 22.5 times 5.8. I get 130.5, and I'm dividing that by 3. 43.5. The volume is 43.5 centimeters cubed. And this is why it's so important to write your units. They're telling us the density of this steel part, or I suppose of steel in general, is 9.4 grams per cubic centimeter, per centimeter cubed. And we did unit rate when we did our unit on proportional reasoning. We talked about unit rate. When they say per cubic centimeter, they mean per 1 cubic centimeter. So you could figure out how many grams for 43.5 cubic centimeters. That's one way to do it. Or you could just realize that if each cubic centimeter weighs 9.4 grams, if I had 2 cubic centimeters, it would be 9.4 times 2. If I have 43.5 cubic centimeters, it's just 9.4 times 43.5. I mean, wouldn't that be what we'd get if we did cross products? 43.5 times 9.4, and then just divide that by 1 and you get x. So the number of grams will equal that volume that we found multiplied by 9.4, which is 408 and 9/10 grams. Let's make sure, there it is. So that's correct. Number 11, a pyramid fits snugly inside a 6-inch cube as shown. I happen to have a pyramid fitting snugly inside of a cube. Can you see it? See, this pyramid has the same base as the cube. They're congruent squares. And also the same height. You can tell the height's the same, because when you put the pyramid inside the cube, the height is the same. But the pyramid's obviously taking up a lot less space. You know exactly what fraction of the space it's taking, but let's read this. A pyramid fits snugly inside a 6-inch cube as shown. What is the volume of the shaded region inside the cube but outside the pyramid? So I suppose, let's imagine you filled up the cube with water, and then you stuck the pyramid in, and a bunch of water spilled out because the pyramid took up some of that space of the water. It's asking how much volume is in here, but not in here. And so that's the volume of the cube minus the volume of the pyramid. The volume of the cube, it's a prism, so it's area of the base times the height. The volume of the pyramid is 1/3 times the area of the base times the height. But they have the same base shape, they have the same square base. So if you think of this as a thing, if you think of area of the base times the height as a thing, I have one of this thing here minus 1/3 of this thing there. Wouldn't that be 2/3 of that thing, of that product? And so really the shortcut here is just taking 2/3 rather than doing them separately and doing the subtraction. But if you did them separately and did the subtraction, you get the right answer also. But area of the base is 6 times 6, or 36. And then 2/3 times 36 times, well, the height, it's a cube, so the height's also 6. 1/3 of 36 is 12. 2/3 of 36 is 24. 24 times 6 is 144 inches cubed. That's this whole big space right there. Lastly, 2 popcorn boxes are shown below. The boxes have congruent openings. That's telling you that this base shape is the same. And equal heights. It's telling you that this and this, they have the same, H is the same. If the larger box, this is clearly the large box, sells for $3, what is a fair price for the smaller box? You know that the pyramid is 1/3 the volume of the cube, or any prism with the same base and the same height. And so this must cost 1/3 as much as this, so $1. Okay, class dismissed.